All right, welcome back. How was the quiz? Yeah, I know, it was a tough one. That one where it gives you the values of the function at different points and the derivatives at the different points. As long as you write down the formula, u's and u primes and v's and v primes, once you've got the formula written down, you're just substituting numbers in. Hopefully you realize that. Hopefully that one wasn't so bad. Moving on. Now we're going to talk about a particularly difficult, annoying problem, but this is one that the AP loves. At first it's going to be very confusing, very hard. So at the end of today, with the quiz and with the examples we're going to do today and all the notes, you might walk out of here a little bit dizzy today, and it can be kind of a difficult day today. Related rates. What exactly are related rates? Well, we know rate of change, like the rate of change in a position function over time is the velocity function. Now here we were just dealing with the rate of change of position. That was the only variable. But what if we have multiple variables going on? For example, think of a cylinder for a moment. A cylinder has two measurements. It has a radius and a height. Now if the cylinder is getting bigger and bigger and bigger, then we could talk about the rate of change of the radius and the rate of change of the height compared to the rate of change of volume, for example. Maybe the base of the cylinder isn't getting any bigger. Think about a cup, filling it up full of water. So the volume is changing, dV dt, but it is related to the changing height, dH dt. I know, very confusing, very frustrating. And we'll take a look at some examples. Hopefully by the end of tomorrow, we'll be okay, and we'll figure this out. The first thing I want to do is just talk about a general strategy, a strategy for dealing with related rate problems. So I'm going to ask you to take some notes and write some things down. So here we go. A related rate problem strategy. And I have 5 different or 6 different steps here for us to look at when dealing with a related rate problem. So I want to write these down, talk briefly about them, and then this is a short video. In the next video, we'll start doing example problems. So the first thing when we're dealing with a related rate problem is we want to make sure that we draw a picture and name all the variables and the constants. So draw a picture, a diagram, what's going on, name all the variables, put that in the picture. We're going to use t for time. And we can assume that all variables are differentiable functions of time. We're always going to differentiate with respect to time, something changing over time. So draw a picture and name the variables and all the constants. Use t for time, and all the variables and all the equations are going to be differentiable functions with respect to time. All right, next, we're going to write down all of the numerical information in terms of the different symbols that we have. Are we talking about the length of something, the height of something, the radius, volume, surface area? What are we dealing with here? For example, if I'm dealing with a circle, circle's nice and easy. Area equals pi r squared, area of a circle. Well, the changing area, dA dt, is related to the changing radius, dr dt. Obviously, as the radius is getting bigger, the area of the circle is getting bigger. Write down the numerical information in terms of the symbols that you have chosen. Next, we're going to write down what we're asked to find. Now, this is important. What are you trying to find? It's usually going to be some sort of rate expressed as a derivative. So again, if I talk about that circle, maybe I'm trying to find the changing area when the radius is a certain point. So dA dt, or maybe I'm trying to find the distance between 2 points. dD dt, the distance between 2 points. What is it that I'm trying to find? So write down what we're asked to find. It's usually a rate expressed as a derivative. Next, make sure you're writing all this down, please. Next, we're going to write an equation that relates all the variables together. Sometimes this is easy as a formula. Again, going back to the circle, if we want to relate the changing rate to the changing area, A equals pi r squared. gives me a formula that has all of the variables in it that we're interested in. So write down an equation that relates all of the variables. Now you might have to combine two or more equations to get a single equation that relates the variables whose rate you want to know, given the variables whose rates you already know. Let me give you a moment to write that down. Write an equation that relates the variables. You may have to combine two or more equations to get a single equation that relates the variables whose rates you want to find and the variables whose rates you already know. Next, differentiate. We're going to take the derivative with respect to t. And this is when we're going to use all of our tools about finding derivatives. Most of the time it's going to be implicitly. We're going to have multiple variables in there that we're going to have to take derivatives of. So we're going to differentiate with respect to time. And then when we've got all the different rates all over the place, we want to solve this in terms of the rate we're trying to find. So differentiate with respect to t, and then express the rate that you want in terms of the rate and variables whose values you already know. In other words, take this new equation and solve it for the rate that you want to know. And then everything else we should know. All of the other variables and all of the other rates should be given us in the problem. And then finally, we're going to evaluate. We're going to use the known variables to find the unknown rate. We're going to, once we've got this equation solved for the rate we're trying to find, we'll substitute back in all of the things we know, all of the rates we know, all of the values of the variables we know, and we will be able to evaluate and find the missing rate. So here it is, kind of a general strategy for dealing with related rates problems. Some of it might not make sense, so you can't picture what is this going to look like, what is it going to feel like. That's okay. When we get back after this, we will look at our first example today, and then we'll look at several examples tomorrow. All right, so I'm going to pause the video here, and then the next example will actually have a problem worked out for us. We'll apply all of this. All right, talk to you in a minute.